Hi, everyone. These are answers to our motion final practice test. First question is, if you have a 1 kilogram object in Amplify and you hit it with one force arrow, then it's going to accelerate by 1 centimeter per second. So this is a pretty easy one. It was a big idea, so we included it in here. And it was kind of where we jumped into everything else from. So this was a demonstration we did in class, guys. When we had the spring car spring the ball into the air, why didn't the ball stop with the car? When you saw that, the ball actually landed way out in front of the car. Well, the reason is since the ball was in the air when we applied the force to the car, the force did not get applied to the ball because at that point it was separated from the car. Newton's first law says that an object won't change what it's doing without a new force. And the ball didn't get the new force, so it just kept doing what it was doing before, which was flying forward. This is really just a moving version of what we did with the chip and the card and the cup, where we had the chip sitting on the card on top of the cup. We put a force on the card, but that force was not applied to the chip. So the chip didn't change what it was doing. It just sat there while the card shot out, and then eventually the chip went down into the cup. At any rate, they're both examples of the same thing. And that is this. The spring car was a demonstration of what law? Well, it was Newton's first law of motion. Just explained it in the prior slide. Ratio of mass and speed is known as, that's momentum. If you have a 0.5 kilogram object and a 4 kilogram object that are stopped and you hit them with the same amount of force, tell one fact about their accelerations that you know is going to be true. Well, the fact we know is that the 0.5 kilogram object is going to have a greater acceleration because than the more massive object. Please don't say that it's going to go faster because these could be moving and we could slow them down. All we know is that the lighter object will change more. Its motion will change more than the heavier object. This idea is very important in the last question on the practice test that you did on the spaceship. But anytime you have two different mass objects and you hit them with the same amount of force, the lighter of the two will have the greater acceleration. Okay, so here we had to complete the missing parts of the table, and the key to this is remembering Newton's second law, which is this. Force always is equal to the mass times the acceleration. This is the mass column, this is the acceleration column, and so what we see is, well, 1 times whatever this mass is has got to equal 4. Well, there's only one number times 1 that equals 4, and that's 4. This one, mass times acceleration will equal our force. Well, 4 times 2 equals 8. And finally, this one works like the first one. 10 times whatever this mass is equals 5. And so 10 times what number equals 5? Well, the only number times 10 that equals 5 is 0.05. So this table is much easier if you apply our Newton's second law equation to it. Next one, all of the answer in the table in question 6 are examples of, and I've just mentioned it about 5 times, Newton's second law, which is force equals mass times acceleration, which we just showed in the table. 8, anytime we have two objects collide, what will be true about the forces on both objects? Well, we know that the force on both objects are going to be the same. That's what Newton's third law tells us. And that's what we saw in Amplify when we crashed objects into each other, where one was half the mass of the other. The half mass one always had double the acceleration, and that only happens when the same force is applied to both. Why does your arm get sore if you continuously throw a ball? Well, your arm gets sore because when you push on the ball pushes back onto your arm. This was demonstrated in the class with the ball and the skateboard. When the student applied a force on the ball, the equal force that the ball applied on him made them move backward. Questions 8 and 9 are examples of this law. Well, it's an example of Newton's third law. In both cases, a force applied in one direction created an equal force in the opposite direction. And that is Newton's third law. Finally, this goes kind of to our boxes question in class. Two spaceships collide head on. Spaceship one's motion changes from 4 centimeters a second to 4 centimeters a second in the opposite direction. Spaceship two's motion goes from 7 centimeters per second down to 1 centimeter per second. Which spaceship had the greater acceleration? Well, spaceship one had a greater acceleration. It had an acceleration of 8 centimeters per second. It had to have an acceleration of 4 to stop, and then another 4 to go in the other direction, 4 centimeters per second, whereas spaceship two just slowed down from 7 to 1. That's an acceleration of 6 centimeters a second. So spaceship one had the greater acceleration. Which spaceship received a greater force? Well, Newton's third law says that they both got the same amount of force. It wasn't more or less on either one of them. And it brings us to the final question, which spaceship was least massive? Well, spaceship one was the least massive. And the reason it was the least massive is because when the same force was applied to both spaceships, it had, meaning spaceship one, had the greatest acceleration. This goes right back to question 5 when it said, what can you say about when any two objects that are different masses get hit with the same force? It says that the least massive object will have a greater acceleration. Here we had spaceship one having the greatest acceleration. Newton's third law says that both of them got hit by the same force. And because we know that both of them were hit with the same force and one of them had a greater acceleration, the one with the greatest acceleration had to be the least massive. And that's it for our practice test for our motion final. And thanks for watching.